I start recording the session. Before starting the presentations, is there anyone has any question for today's sessions or anything about project management? You can open your microphone or other option as right in the chat box. Taha, if you are ready, you can upload your presentation and start your preparation. I understand that there is no questions for the lecture or the sessions.
Hello, sir. Can you see my presentation?
Yes, Taha. You can proceed.
Hello, everybody. I hope you are well and everything is okay. As I am today, I am a little bit busy. For this reason, our research assistant Onur will be the lecturer. Please listen him carefully and take into consideration his suggestion for further for evaluation of your homework for further situation of projects. Have a good time. See you anyway. Thank you very much, Onur. Thank you very much for your kind assistant. First of all, we have to listen. If I don't know, are there any other people that can present their homework? I don't know. If there is anyone, you can listen them. Okay. Goodbye. See you later. Maybe I sometime I can participate to your lecture, but I don't know what will be the situation due to the internet access problem. Okay.
Okay, sir. Have a nice flight.
Good luck. Good luck. Good luck.
Yes, Taha, we are listening to you.
Welcome to my presentation on the Sustainable Shopping Lista project. Purpose of the project: easing the transition. Our goal was to develop an app that encourages and facilitates sustainable shopping habits for users, making it easier for them to make eco-friendly choices. Clearly stated projects aim to promote sustainable shopping habits and simplify eco-friendly choices for users. Reducing environmental impact. We aim to mitigate the negative impact of consumerism by promoting responsible and conscious shopping practices that prioritize environmental sustainability. Fostering sustainability communities. By connecting users with local sustainable businesses and promoting conscious consumerism, our app aimed to create a supportive community dedicated to sustainable living. Problem statement: limited awareness, lack of knowledge about sustainable alternatives and their benefits, complexity, difficulty in finding and accessing eco-friendly products and businesses, inefficient planning, inconvenience in organizing and managing sustainable shopping lists. These conscious statements highlight challenges. Overcoming these hurdles is crucial for fostering sustainable shopping habits. Solution overview: educational resources, curated content on sustainable living and product information, product recommendation, smart algorithms suggesting eco-friendly alternatives based on user preferences, local businesses directory, database of sustainable businesses with user ratings and reviews, smart shopping list, customizable list based on user preferences, including product details and store locations. These solutions encompass education resources, personalized product recommendations, a directory of local sustainable businesses, and smart shopping list to collectively enhance user awareness, accessibility, informed decision-making, and planning for sustainable living. Key features: barcode scanner instantly identifies sustainable products by scanning their barcode. Social integration share sustainable finds and achievements with friends and social media followers. Community challenges engage with others through sustainable goals, challenges, and rewards. Notifications receive alerts for eco-friendly deals, discounts, and local events. These key features uh, collectively enhance user engagement, sharing awareness, and creating a dynamic and supportive community focused on sustainable living. Development process: first, research and planning, conducted in deep market research and user surveys to define app requirements and target audience. Second, design and prototyping, created wireframes and interactive prototypes to validate user flows and interface design. Third one, development and testing, implemented features using agile development methodologies, conducted rigorous testing to ensure app stability and performance. Fourth, launch and user feedback, released the app to the public and actively collected user feedback for continuous improvement and feature enhancement.
Taha, can I interrupt here?
Yeah,
This looks like your timeline of the project. It's better if you put the times for each parts, like research and planning, how much time you are going to spend in this section, and designing and prototyping, which is looks like cross section with also planning. It's better to put them into timeline.
okay, I will put it in then.
Yeah. Okay, let's proceed.
Okay. This development process involves user-centric launch strategy, all aimed at ensuring a robust and user-friendly sustainable shopping app. Challenges encountered: first, data integration, integrating accurate and up-to-date product data from various sources proved to be a complex task. Second, user engagement, encouraging consistent app usage and maintaining user engagement posed a challenge. Third, scalability, ensuring the app's scalability to handle a large user base and increasing data volumes required careful planning and optimization. This encountered challenge underlined the intricacies involved in developing and maintaining. Lessons learned. User-centric approach. Putting the user at the center of the design process lead to a more intuitive and engaging app experience. Continuous iteration. Being responsive to user feedback helped us identify and address issues, answering ongoing app improvement. These lessons highlight the significance of placing users at the forefront of the design process and embracing continuous iteration based on user feedback for the development and improvement of a successful, sustainable shopping app. Next steps: expansion, scaling the app to support more regions and collaborate with additional sustainable businesses. Gamification, introducing gamification elements to make sustainable shopping more engaging and rewarding. Partnerships, forging strategic partnerships with environmental organizations and influencers to amplify our impact. These next steps involve expanding the app's reach, enhancing user engagement through gamification, and strategically partnering with organizations and influencers to amplify the project's environmental impact and community involvement.
Okay,
And thank you listening me. Those are the resources.
thank you very much. The next step is you need to put some investment values and the operational expenditures for your project. As I understand, because I did not see any investment values there, you just prepare the problem state and you put the solution and the development phases. You also need to put some numbers and smart targets to consideration of the stakeholders. Okay, thank you for your presentation.
Okay,
Is there anyone else who is going to present their or his or her presentation today? As I understand, there's no one else left here, and so okay, then I will present you today the project appraisal techniques like financial evolutions of the project and financial comparisons, and which techniques you need to use for the future value of today's investing money. Let me present my you can see right now the pages, and I'm going to share screen. Okay, can you see the screen? If so, please someone tell me. Yes, okay. Today I'm going to present you project appraisal techniques, and okay, we study our feasibility study right up to now, and now we are going to present it to stakeholders so with the evolution of the investment. And first we need to define a set for investment project for consideration. And then the second step, you can see here the evaluation steps of economical evaluation steps of the project, and then you are going to establish the planning, and this is called also analysis period of the defined stage, and then estimate the cash flow for the profile for each project. The time value of the money is going to be calculated and examine this objective and the established criteria for the measure effectiveness of the project. And then you are going to apply the evaluation techniques, compare them, and preliminary, and then at the end we are going to perform sensitivity analysis. If the result of the sensitivity analysis will give us two results at the end. The project is accepted and proceed to execution phase, or otherwise this project will be rejected and put on the shelves, unfortunately. And we say cash flow right now. There are some terms I want to mention before starting the appraisal techniques. Like financial cash flow, it is the project stream of cash cost and benefits, or expenditures and receipts which is generated by projects over its economic lifetime. You cannot produce the project with the financial cash flow absence. Project life is started from the constructing of the project and will be the length of economic life of the project where the cash flow continues during the capital cost is our investment cost, which is fixed cost is acquiring the fixed asset like plant and equipment, startup cost, working capital, etc. Operating costs are our variable costs during the operation, like water, waste removal, raw material, etc. I would like to give a 5-minute break. I need to take it on. Sorry for this pause. My door is ranked. I need to take this. And treatment taxes is applied by the government for our money spending and for the income. And the project benefit is our money that remains after the our expenditures, and net benefits is at the end the money left in our hands. It's easily, if we say. There are two kinds of financial appraisal. One is discounted and the second one is undiscounted. What are the differences for these two techniques? We are going to consider here discounted techniques, but there's also undiscounted techniques which we are not consider about the highly mathematical calculations, like ranking by inspection, payback period, proceed per unit outlay, and average annual proceeds per unit outlay. And the discounted techniques are mostly we are interested in, which are net present value, internal rate of returns, and net benefit investment ratio. In order to determine whether the future cash inflow we are justify the present initial investment, and we must compare money spent today with the money received in the future. What does it mean? The time value of the money influences many production decisions. Everyone refers money today to money in the future. Therefore, in order to invest money today in production today, one must be guaranteed the return of our money in the future is equal, especially no one wants that equal, but at least it is equal or greater than the money we invested today. If you have any questions, you can interrupt me and ask during the presentation. Please do not hesitate. You can write on the chat. I'm seeing the chat part also, or you can directly ask through your microphone. And the presence of the money now instead of the money in the future arises from three basic reasons. Uncertainty of the future influences presences because one is never sure what will take place tomorrow. And alternative uses, it will determine whether one investment in one project or another. I think I mentioned that thing in my previous presentation 3 or 4 weeks ago, I guess. And we all know very well this concept, inflation, that affects the purchasing power of the money. You understand that? Because these things will be your project's next step for evaluation. Okay, let's talk about the discounted cash flow. It's actually a very simple method to estimate the length of the time required for the investment to itself. That is the number of years required to a company to cover its original investment from the net cash inflows. To do that, we need some data, like yields a stream of benefits, stream of costs, and of course the year timeline, and the discounted rate, which should be constant. This discounted rate value will be given you by your financial department or the bank system. You can find it also in some some banks' websites. And here you can see the cash flow of the project during the time. In 0 time, your cash flow is B0 minus C0, which is the benefits minus the stream cost of the year. You can see them clear in the applications in the next slide. And in project analysis, any cost or benefits of the project that are received in future periods are discounted or deflated by some factors, R, which is discounted rate, to reflect their lower value to the individual than currently available income. This factor is used to discount future cost, and its benefits is called discounted rate and is usually expressed in percentage. Okay, you can see here comparison of two projects. One is buying, oh, I write it wrong, buying an aerator, and project B is feeding shed. And we are considering this project for 7 years lifetime. And we are putting 2 million United States dollars for each project. These values are times 1,000 United States dollars, the money part. And our first project has a cash flow of, there's no cash flow in the first year. And after first year, the cash flow is 700, 600, 500, 400, goes on to 100. Every year is reducing. And discounted factor is 12%. And in the first year, it's 1. I will also show you the calculation of this discounted factor number. And the present value of the net cash flow is calculated like this. It's the multiplication of the discounted factor times net cash flow of today, or the time that cash flows. And also the same calculations is done for the second project. In the next slide, you can see the calculations, and you see here we invested. Can you see my mouse pointer? Or maybe I can put here pointer options. Pointer, yeah, laser pointer, better. Okay, you can see here our investments are in both project is 2,000, and during the year, with the calculation, the net cash flow, this column is the summation of the present value of the net cash flow. If we sum every year our income present value, you see after 6 years we can pass the 2,000, which means our investment will return between 6th and 7th year. And in project B, our investment will return between 5th and 6th year. And if I were a stakeholder of this company and someone present me these two projects and I need to put 2 million United States dollar either projects, I will choose project B, because project B will return in 5.8 years. But for example, if there's a time limitation and I need my money returned back in 4 years, I will reject both projects because none of the project will return in 4 years. We use these techniques to evaluate the return time of the project. As you can see, discounted payback period in the name of this technique. We are calculating the payback time, return time of the project with discounted rate. This discounted rate is minimum, mostly minimum, the banking credit rates, the interest rates. I put there 12, but probably these days it will be something like 30% or something per year. Okay, in the next slide, I'm going to tell you the net present value, NPV. Is there anyone who heard about NPV before? At least the abbreviation NPV. This is the most popular technique for financial evaluation of a project. By the way, I'm saying financial evaluation, money or other words for this, but these calculations are done by engineers, and probably half of you will do this kind of calculations during your professional career. Okay, net present value is a discounted cash flow technique again. It is the present value discounted at company's required rate of return on the stream of net cash flow from the project minus the project net investment, as you can see in the second formula. What are we doing there? We are calculating each year's cash flow of present value, and we subtract them from the investment value. And from there, we find a net present value. Also, you can see same the better understanding in the example I will present you in the previous slides. In this formula, it's the summation of the cash flow over. Do you get lecture of anything about engineering economics, introduction to economics, and you know the calculation of the interest rates, or maybe in any mathematical lecture? Do you familiar with this formula? No? Okay, maybe you can make a research for calculating the interest rates so you can understand the formula better. Okay, here the cash flow per year is divided by 1 plus the interest rate. It's the interest rate or marginal cost of capital. For every year, we can take the multitude of this summation and we divide the cash flow to this value, and then we sum up all this value and we subtract our investment, we can get the net present value of the project. It's the model is the mathematical modeling that the net cash flow of the project are discounted and then added to yield the net present value. The initial investment is negative because we are giving money here, and it represents a cash flow during the time. And an investment project accepted if net present value over the year is greater than 0, and the project or investment rejected if this value is negative. And if net present value is equal to 0, this decision maker would be indifferent and stay doing nothing, either rejecting or accepting. In this kind of situations, it's better to evaluate the project from the feasibility study to lower the investment value, because mostly the cash flow is going to be constant for the project, so you need to reduce your investment. And in case of there is cash outflow and cash inflow during the lifetime of the project, instead of you are putting them just cash flow P, you can put the benefits minus costs, which also give you the cash flow of the project during the years. And another concept is benefit cost ratio, which is also called profitability index. This method is usually producing same result with net present value and internal rate of return, which will be our next subject here. And it's very important in separating project in varying sizes, because it's a ratio, so you get a value per unit, which means the sizes of the project is indifferent. Here you don't consider the size, you consider the unit investment per project. And here, if the benefit cost ratio is equal to or greater than 1, you should accept the project, and if this value is less than 1, which means the project should be rejected. This rejected also means the project will get no additional value to you in the future. This is why you are going to reject the project. No one wants to lose money, right? Here is another example for benefits cost ratio example. And here you can see an investment and of $40 million, and during the year also there are additional investments to the project, and at the end, after 4 years, there's 50,000 United States dollar, 50 million United States dollar investment in the project. And here is net present value is present value of net benefits minus present value of the investment, which is if we consider the discounted rates here, the present value of the net benefits are $53 million and $39,000, and present value of the investment is $47 million $661,000. And if we do the calculations, we get the NPV of, you see the positive value of NPV 5,378, and the benefit cost ratio of 1.11, which is greater than 1, and where we should choose this project and proceed to the execution part. Okay, everything is clear for you, or is there anything you want to ask about up to this point? Because my next slide will be IRR, internal rate of returns. Okay, when we come to this calculation, is there any hand option here? Okay, you remember I put there 12% discounted factor, right? You remember the formula that I showed you? No? One over 1 plus interest rate over time. In the first year, time is 0, 1, 2, 3, 4. And in first year, I is 0, 1 over 0, 1, which is 1.0. And in the first, after 1 year, 1 over, and this time this is here 0.12, and this is 1. If you do the math here, 0.893, and in second year we put here 2, and if you do the calculations, this is constant, by the way. If you do the calculations, it's 0.793, and in the third year 0.712, and in the fourth year 0.636. And if I go back to my please tell me when you see the screen. Yes, these values are calculated as this, as like I write on the whiteboard. This is how you calculate discounted factors. I'm checking the chat part. There's no questions. Okay, good. It's good you can understand everything here. And let's consider about the internal rate of returns. To calculate internal rate of returns, you remember here we calculate NPV. NPV, you remember that NPV should be positive to accept the project. Internal rate of returns, when we're calculating internal rate of returns, we are going to calculate this I, and it will give us the minimum discounted factor, the interest rate we need to make our cash flow to zero. And normally it's not easy to calculate this rate, but this is why we are forcing the formula and setting the PV to equal to zero. And then we calculate the IRR, which is this I value. We subtract this I from the formula and calculate it. It's basic mathematics. That's all. And to accepting this IRR, we need also the required rate of returns, which is going to be your buses, your shared stakeholders, and this also sometimes called minimum acceptable rate of returns. And here we are calculating the limits of the project, where we can accept the project. And if IRR is greater than this minimum rate of return, and then the project is accepted. And if it's lower than this minimum rate of return, the project is rejected. And as again, if it's equal to each other, you need to do some evaluation of your feasibility study. Here is another example. There is 25 million United States dollar of initial investment in the project, and the cash flow is given in the table. Again, but here in this table, I compare two different discount rates. Discount rate RA, 12%, and discount rate RB, which is 20%. And if I calculate the NPVs for these discount rates, I can see that the 12% is my project is positive, and 20% my project NPV is negative, which is not acceptable. But this two value gives me that the IRR should be between these values to make the NPV to zero. And how I can calculate this IRR value? This is the formula that is for to calculate IRR. 12 my discount rate here, and 28,447 is my present value after 4 years for 12% interest rate, and 25,000 is my initial investment. Here also it's written PV is present value of cash flow at RA, and C is my capital investment, initial investment, and AR is difference between two interest rates, and the subtraction of this project is the difference between my net present values. And here I can calculate the internal rate of return as 19.3%, which is, I also mentioned that it should be between 12 to 20 and close to 20, as if this value is very small. And here 19.3% IRR is calculated for this example. And at the end, I can say that there are rules for evaluating project, which is discounted payback period should be minimum to accepting the project when during the evaluation, or NPV should be bigger than 0, or benefit cost ratio should be greater than 1, or IRR should be greater than the bank interest rates. Is there any question? This is my presentation for cash flows and net today, the future value of today's investments. You can see that there is no questions at all. I understand you are very clear about the presentation. Okay, if so, clear, great. Okay, then another point I would like to share is any questions? Okay, then I would like to show you some formulas for these financial calculations where you can use during the project evaluation. You can see my screen, right? Okay. For calculating any projects, you need some values beside the investment cost and project cost, which is you need also the operating cost, land costs, etc., building costs, and there are some evaluation books to calculate these kind of things. For example, in my projects, I am producing ammonium nitrate from nitric acid and ammonia. Here you can see butter limit investment equation. This one. I need the value for C and T, which is given in this table. For C, for ammonium nitrate and ammonia, the C formula is here, and in the tables and the book, I can also find the other parameters to calculate the values, because during the project there's no plant, no production facility, and no production. I don't know the exact value of this operating cost, but all of us should do some estimations for our investments and the cash flow in the future, because as you remember in the presentations examples, there is year zero investment, and also there is cash flows during the years. How can we estimate this cash flow during today? For the future is like this. We are calculating these values depend on some empirical formulas prepared during the years by very experienced people. And again, here you can say the capacity of the plant and the consumptions. And for ammonia with raw material naphtha, requirements per ton of naphtha in these times, because this book is very old, and in these times ammonia is produced by naphtha in 70s probably. And here are the requirements of manufactured raw material with variable costs. This is the tons per ton of product. For ammonium nitrate, you need 290 kilogram of ammonia. For ammonium nitrate, you need 220 kilogram of ammonia, and for urea, you need 580 kilogram of ammonia. And for again ammonium nitrate, you need 800 kilogram of nitric acid. This is 1 ton of product. And with these calculations, you are going to estimate your operating cost and needs. Here also utility needs like steam, electricity, cooling water, and plant water and air needed for the production, and also equipment costs per ton of product, like absorber, scrubber, compressor, turbine, etc. And for your project, if it's a production facility, you need equipment, so you need to find the equipment cost with these empirical formulas, and you need your operational cost, which you can find with these kind of empirical formulas. With a simple research, you can find this kind of books. This book is mostly specialized for some inorganic chemicals. Also for my project, I prepared a timeline. I mentioned Taha about this timeline. Let me show you this. This is a timeline of my project. You can see I put them in work packages like project management, project studies, execution, and commissioning and startup and handover. Probably at the end I should put here handover, like 460 handover. And this is where your project will be ended. It should be either here after the performance test or after the sustainable test here. You can see, I will explain you this later. Let me explain the other parts here in the beginning. In the beginning of your project, after you finish your feasibility studies, mostly, or before you start the feasibility study, depending on the project type, you have to do the kickoff meeting. This kickoff meeting will be done between each parties, like engineering and the investor and construction companies, contractors, and every stakeholder will attend this meeting. And in this kickoff meeting, you are fixing all the initial data and you prepare design basis, and this design basis fixed in this meeting, and throughout these 36 months nothing will be changed in this design basis. And you see the project coordination goes throughout the project lifetime, and you need to monitor your project during this project lifetime in several times, and at the end you should give a project report, and time to time you have to give public speech and public hearings to announce the news about your project. And the second structure is project studies, which is feasibility study. All kinds of studies should be finished at the end of approximately 1 year. And during these studies also execution phase start with project design package prepared, and with this study also basic engineering and detailed engineering packages started to prepare, which are including all equipment data. When some part of the project is clear, you can start procurement activities of main equipments, because some of the equipments can be delivered in 1 year, some of them more than 1 year, and you should finish the studies with this design packages, and then you will start procuring these equipments. And also the transportation of these equipments from different part of the world will be taken. And site preparation works also start with as in some phases, after some time started the PDP packages, and it will continue up to feed package preparation, and then you start installation. You see there is the installation starts right after the site preparation ends. You can start installation before the site preparation, because site should be ready to start all the construction and installation works. But you can start here. Another point, equipment is steel structure works. This might be start outside of your battery limits, and the equipment installation starts with steel structure works, and also the pipings. And after most of the equipment installation completed, you start mechanical completion works, which means the handover of these mechanical equipments from one team to another. And after the execution phase, the final step for the project is commissioning and startup, where you first build a team for commissioning and startup, and which is mostly after the starts with the ecological studies. This ecological studies, environmental studies, like I don't remember the Turkish name, English name for that, but let me check. Okay, environmental impact assessment should be started here. And with this also you build the commissioning team and start training them. And right before and also with the activities of the pre-commissioning, you also train your team with the site team. And then you start the pre-commissioning activities, which are mostly cleaning of the equipment and pipelines with some solvents or water or steam. And with them, you also start the commissioning activities and start up the plant. At the end of the start of the plant, you are performing factory acceptance test, FAT, and reliability tests, and the performance test. And after you finish everything and the project lifetime is finished, at least 1 year, at least 2 months, you perform sustainability test, which shows you the project. At the end of the project, the plant will run sustainable conditions without losing any production. And another thing, from our project is my project for this. Sorry. Anyone ask something? I hear someone is telling. Okay. My project is 900 metric ton per day weak nitric acid and 1,140 metric ton of ammonium nitrate solution and technical ammonium nitrate prilling plant, which will be produce low density ammonium nitrate and high density ammonium nitrate, and the plant will be located Demirciköy, Sinop, Turkey, and the plant will be utilized approximately 34 hectare land for installation, also some additional part for utilities. The main raw material of this production facility will be ammonia, and it will be imported through the Sinop port facilities. I'm not sure about the Sinop port will handle this kind of application. This is why I put this city name in red. But I will put these operation facilities in this project in or out, depending on the port capability of the operation of ammonia. Anyhow, ammonia storage tanks also will be installed in terminal area, and which will be close to the project site in this region, because this is the project location. Project will be located, and this area is also industrial zone for Sinop region. This is why I choose this area, because other part of this region is mostly touristical or has many natural resources, and I don't want to spoil this kind of resources, and I don't want to get a grudge from the citizen of Sinop. And additionally, we need natural gas for this project, and we are going to get this natural gas from the Turkish main pipeline, which has approximately 70 bar pressure natural gas. And of course, we need water, which can be taken from the river close to the area. Also, we can use seawater to cooling purposes from the Black Sea. And I checked the seawater temperature, which is sufficient to cool down the plant. Nitric acid will be performed from ammonia and serve as an intermediate for manufacturing of technical ammonium nitrate. And ammonium nitrate will sent by trucks to the customers or other storage facilities, and the on-stream factor for the plant is 330 days per year. On-stream factor means that the plant will be run 330 days per year, and this is one of the main calculations for the production facilities. And in the second part, I give some information about the production process and what is technical ammonium nitrate and what's the purpose, and I give there's a document best available technologies the European Union released in 2011 for these kind of processes, and I get this information from there. And when you get information from somewhere, you put some footnotes to give these values. And after that, I give information, the usage of the ammonium nitrate and the block diagram of the facilities, and here are which units I need to produce these intermediates and final products, and which units I need, and which utilities I'm going to use. I haven't put them here in the project yet, but I could do also some calculations for the investment cost and operational costs and evaluate the results. And I calculate the values of the cash flows and the return of the investment also. And here are the soil works I need to do throughout the project. I think that's it for today. If there's not anyone need to tell anything, I would like to finish today's course here. Is it okay for everyone? Or then I would like to end today's session, and I would like to thank you all. It's like my childhood in 80s. Everyone is so quiet and in silence. You can ask me anything throughout the emails, or you can find me also in LinkedIn with my name and ask a question about this lecture or in general in project development or for career development. So I would like to be happy to answer your questions. I'm stopping the